In AC analysis, today we will see AC factors and power calculations. So this is another dimension to look at in AC. Main focus is power calculations. Even the power calculations also we saw single tone, single frequency. Today I will be dealing more of multi-tone frequencies. That means multiple frequencies. First we will talk about AC factors. Second part of the lecture will talk about power calculations. So the first fundamental definitions. Average value, it is a value of parameter delivered to a load in a specified interval time. That means, for example, you have I of t as a current. DC current is 1 by 2 pi integral 0 to t I of t dt. So this is the expression for average, please. Average value means DC content. That's why it can be called as a DC value or average value. Second definition. Root means square value, RMS value. If you see this RMS, IRMS, root 1 by 2 pi is mean square. So root mean square value is defined. Third definition, form factor. RMS value of signal by DC value. Then crest factor or peak factor. It's more called as a crest factor, can also call as a peak factor, because it's called peak factor because it is defined as peak value by RMS value. Then what is how to denote them mathematically? IRMS by IDC is form factor. IM means maximum value by IRMS is peak factor. So this peak factor and form factors we can calculate. And another factor that we are going to talk or we should know is ripple factor. Ripple factor, we call it as R for ripple. RMS value of ripple by DC. RMS by DC. If you convert the ripple factor in terms of form factor, it's root of form factor square minus 1. So if you know form factor, you can make a square root and calculate ripple factor. So these are the different factors involved. We'll take certain problems to understand how to calculate all these factors. So let us calculate peak factor, form factor, average value, RMS value of different waveforms. If you know the definition, you can easily calculate. Actually, these two are important, average value, RMS value. After calculating these two, you can easily manage these two. That's why let us see some problem. Problem number 1. Calculate form factor, ripple factor, crest factor for the waveform given. Please understand, for the first waveform I am calculating in detail. For other waveforms I have given answers because see the procedure here and you yourself develop and cross check with the answers I have given. Let's go with the problem 1. This is basically, we call it as half wave rectifier. 0 to pi, pi to 2 pi. Half is missing. That's why we say half wave is passed or removed. That's called rectifier. Now what is the definition? I of t is equal to Im sin t, 0 to pi. It is 0 for pi to 2 pi. In all our dealings, theta is omega naught t. That is 2 pi by t into t. And in the process, the time period is 2 pi. If time period is 2 pi, therefore 2 pi by 2 pi becomes t. So whether you call t or theta, both are same because theta is now became t. That's a very important observation. Students are asking me most of the time, sir, why are you taking t in the place of theta? Now I give an answer. Theta is generally omega naught t. and that is equal to t if the time period is 2 pi. That's why with this definition, average value is 1 by 2 pi, 0 to 2 pi. I of t is the original definition. If I substitute 0 to pi Im sin t as defined here, this I am substituting here. Then if you look at here, this 0 I am substituting here. If you analyze and integrate and substitute the limits, you will get Im by pi. So average value is Im by pi. Please understand that. That's the meaning of average value. Second one, RMS value. As I told you the definition, RMS means root, mean, square. Enjoy this concept, root, mean, square. And you substitute here 0 to t, 0 to pi, you are going to have Im, and remaining is not required because it is 0. If you calculate, you will get Im by 2. So RMS value is Im by 2, DC value is Im by pi. Now you can easily calculate these values. Form factor is what? RMS by DC, Im by 2 by Im by pi, 1.57. Generally, form factor people think it is 1.11. That is true. 1.11 is for full wave or for ordinary sine wave, not for half wave. And most of the times in generator expression, when you are even studying electrical machines, we use 1.11 because that we generate sinusoidal wave. So for our sinusoidal wave that comes to our home, the form factor is 1.11, but not for half wave. So crest factor is Im by IRMS, Im cancel, 2 comes here. Ripple factor is root of 1.57 square minus 1, 1.21. So this is the procedure I have illustrated for you to go and calculate your own. Okay, so calculate for all the rest of the waveforms I am going to show you. Take it as a homework and cross check with my answers. So let's go to second problem. This is fully rectified wave. What is the definition here? 0 to pi Im sin, pi to 2 pi is not Im sin, it is minus Im sin. If you calculate, average value is 2m by pi, RMS is Vm by root 2, crest factor is root 2, form factor is 1. As I told you, for full wave it is 1.11. This is for a full wave Third one, pure sinusoidal. For a pure sinusoidal, DC value is 0. Why DC value is 0? This half cycle and this half cycle, these two are cancelled. When the two half cycles are cancelled, that is called 0. RMS value is Vm by root 2, just like previous. Crest factor, everything is same. But when you say this is DC value is 0, then you may think it as infinity and all that, but that is 1.1. So remember these definitions. Fourth one, square wave. What is the average value for this? Positive portion, negative portion is cancelled. So it should be 0. RMS value, Vm. Crest factor is 1, form factor is also 1. Why? 1 by 1, 1. So like that, you can say RMS by DC. Then triangle wave. Again, average value is 0 because positive value and negative value cancels there. This Vm by root 3. Crest factor root 3, form factor 2 by root 2. Okay. Pulses. Suppose you have some pulse like this, and for that pulse you have to say x, y. So Vm is the peak value, x is the existing period, y is the overall time. So x into pulse time by time period. RMS also Vm into root of x by y, crest factor root of y by x, form factor root of y by x. This is a general expression for given for pulse waves. So these are the different waveforms we have. Suppose sawtooth wave. Sawtooth means this way. What is average value? Now you can't say 0 because there is nothing to cancel on the negative side. So Vm by root 2, IRMS Vm by root 3, crest factor root 3, form factor root 3 by 2. These are the different options we have. So that is all about some factors that we need to study. Now I am turning to the second part of this discussion. More emphasis is on power analysis or power calculations. When we say power, power is classified into three parts. Active power, because it is useful, it is also called useful power. Reactive power, apparent power. So these are the three powers that we have. Let us go by definitions of one by one. First one, active power. It is useful power because any electrical equipment which is worked by using this active powers only. What I mean? You take any electrical appliances where you will calculate active power. That power is Vi cos phi. So this is called active power. Sometimes it is also called real power because cos phi, cos means generally on x-axis. When cos is on x-axis, we generally call that as real axis. Sin is on imaginary axis. That's why real power also we can use this word, and the units are watts. So Vi cos phi is a general power by default. Tomorrow anybody asks you calculate the power, you need to calculate Vi cos phi. That's called active power. Let's go to second power, reactive power. The power which is used to create the electrical flux is nothing but reactive power. It is also called wattless power because we don't consider watts here. Reactive power is defined as Vi sin phi. As I told you, real power on the x-axis Vi cos phi, reactive power Vi sin phi, and units are volt amperes VAR. So this is another dimension of another second category of power called reactive power. But what is the third power normally? Actually in high school level we don't study these two powers. We normally say power is voltage into current, but that's not the real power. That is only apparent power. It's called apparent because we see. So look at this, apparent power. It is a resultant of those two powers. Suppose Vi cos phi plus Vi sin phi, if you put the j there, so you have both powers. Then take the magnitude, p square plus q square. You will have Vi cos square, Vi sin square. So cos square to cos sin phi, what will happen? That's called Vi. So cos plus sin square will become 1, it is Vi. So all that generally we calculate voltage into current is basically volt ampere. So this is called apparent power. It's really called apparent because it look like that. The actual powers are Vi cos phi, Vi sin phi, but this way it look the resultant power. So we call it as Vi. So these are the three powers we are really seeing. Now let me give you power triangle. It's called triangle because, as I told you already, there is a real power, there is a reactive power. If this is Vi cos phi, this is Vi sin phi, then what will happen? This resultant will come. Vi cos phi, Vi sin phi, the resultant is here. So that's why it is called a vectorial addition. As I've been telling, vectors and phasors almost same. In vectors we have a direction, in phasors also we have a direction. Not like exactly direction, but like angle. Angle is acting as this. So from the triangle you can calculate tan phi. What is tan? Tan is generally opposite by adjacent. This is opposite. Sin, opposite by diagonal. Cos, adjacent by diagonal. So very simply with high school mathematics we can make this triangle and also angles from that. We don't need to calculate all the three. You can just calculate any one. Cos you can also calculate. So this is what it means by adjacent, opposite, diagonal. Phi is the angle. Please remember, as I've been telling in AC analysis, when I say phi, it is the angle created by the circuit. If an input is coming with an angle, we don't call phi, we call it as theta, right? Please follow those things. Now, instantaneous power. The power which is delivered to any load instantaneously is a product of instantaneous current and instantaneous voltage, VI. That's called instantaneous power. Then average power. It's the power delivered to the load in a specified time. Average means what? General meaning of average in high school mathematics, sum of components by value, limits. So sum is integral, limits is taken t. Therefore, 1 by t2 minus t1, that limits as sum of this value by average. So average power also can be calculated. Let us assume V of t is Vm cos omega t plus theta. I of t is Im cos omega t plus phi. Then suppose you have that theta. Wantedly I took these two because you cannot take same angle now. You can call it as theta 1 or theta 2, or the best way is theta and phi. Now what will be the average power? Vm cos and Im cos. What I mean to say, this is Vm by root 2, Im by root 2. 1 by root 2, 1 by root 2 will become 1 by 2. So half of Vm Im cos theta plus phi, or algebraic sum of that, you should have to say. So if it is minus, you can put minus. If it is plus, you can put plus. So it's basically, what are the different angles we have? What happened to omega t? Omega t we don't take. As we said, it's a cos value. So depending, this is just an illustration to say how we are going to calculate the powers. Now, power factor. It is a cosine angle between voltage across and current through it that the device produces. Just voltage and current. So let's look at this. Power factor is cos phi. So angle of voltage minus angle of current. The difference between those two angles. That's why minus people normally take difference of those two angles. It can also be defined as I already told you, magnitude of real value by impedance. But always remember, it is easy to say cos can never be going beyond 1. The maximum value of cos is 1. So R by Z. This is the real value by total value or impedance. Now let me take you to problems. The problems we have done already, illustration of 7 problems. Now I am going to go to 8th problem. Calculate power if voltage is 100 sin 337 t and I is 4.2 sin 333 plus 20 plus 2.3 sin 754 t minus 70. Please observe here, as I told you one word. If I am calculating powers of an ordinary single tone signal, that's not required, it's already over. Today main focus is multi-tone signals. Okay. So what exactly I am trying to say, when you are handling multi-tone signals, see the same frequency. In current you have 2 frequencies, in voltage you have only 1 frequency. What is multi-tone? Multi-tone means more than 1 frequency. So 337 existing. So second one has no value. Let me see, show you. 100 by root 2, 4.2 by root 2, cos of minus 20. 0 because in the voltage you don't have 753. So that component is missing. So 2.3 by root 2, cos 70. So this term completely vanish. So 100 by root 2, 4.2 by root 2, cos of minus 20 is the only thing. Don't worry about cos of minus theta, because cos of minus theta is cos theta. So power is calculated for respect to harmonics. This is what I wanted to say. If any harmonic is missing, for that harmonic you should say 0 and then continue. So in this problem, as you observe here once again in the problem, look at here. So 753 component is missing. That's why for that component I have put just a value of 0 here. So this 0 has come because of that. Good. So the answer is 197 watts. This is a multi-tone signal. Again, multi-tone signal. Calculate power. If I of t is 4 plus 5 sin omega t minus cos omega t and RL is equal to this. Actually speaking, you have two things here. One is sin, other is cos. So that means indirectly speaking an angle of 90. How to calculate if I and R is given? As you know, power is I am R square into RL. So 4 square into 20, 5 by root 2 whole square into 20, minus 3 by root 2 whole square into 20. What is this? Y by root 2 here and by root 2 here, but there is nothing here because this 4 is a DC term. And if it is a DC term, please understand 4 square. You can't take by root 2 anything, because if I take you back to the problem, please understand this is 4. No sine, no cos, no angle, nothing is attached. It is a DC term. So I took simply I 4 square into 20, 5 by root all others. When you calculate the power, the total power is 320 plus 250 plus 90 is equal to 660 watts. That's the total power. So let's go to 10th problem. Calculate power if V of t is given 215 sin 337 t, 140 cos 354 t, 70 sin 113 t. This is the voltage given. Please observe current 15 sin 377 t minus 30 plus 4 cos 754 t minus 45 plus 3 cos 113 t minus 60. These are this. The first you need to observe, is there any component missing? In this problem, absolutely no component is missing. Let me show you. 337 is in both. 754 is in both. 70 means 113 is in both. Then why this problem? We can directly do it. Whether we take two components or one component doesn't matter. Could you please observe the main important focus here? Now, if all the components are available, check. Sin here, cos here, cos here, sin here, cos here. The main focus of this problem is when frequency components are same but one is sin, other is cos, what to do? The answer is very simple. Convert both of them into sin or cos. While converting both of them into sin or cos, absolutely 90 degrees difference. That 90 degrees difference, the phase angle should be considered in this problem. That's the main focus. So understand this problem. Now follow the solution. What did I do? 215 by root 2, 15 by root 2 cos 30. That's okay. 140 by root 2, 4 by root 2 cos 45 is also okay. 70 by root 2, 3 by root 2, and this is given as cos 30. Why this is 30? Will you please come with me back to the problem? Here it is how much? 60. How come 60 became 30 angle? Because this is having 0 angle, this is having 60 angle. Therefore, the net angle that we have is 60. But what I am writing there? 30. I am writing 30 for one reason. You know what is the reason? I have put 90 minus 60, that is nothing but 30. Why should I put 90 minus 30? Cos 90 minus 60 is equal to 30 is because cos will become sine. As I told you, you need to convert both of them into same. So please observe that one. That is the only point in this problem. If you lose that focus in this problem, you are losing the whole problem. So please observe and enjoy this 30 there. Remaining is after all very simple. And all these things is substituted. The cos 30 value given. Cos 45 is 1 by root 2. Cos 30 is once again given. If you add this total value, you will get 1685.28 watts. So this is the main focus. Here I have included multi-tone signal. I have also included one sine, other cos. I am giving you different possibilities and different aspects of multi-tone signals to be handled. So that's the interesting thing. Now, next problem, 11. Calculate reactive power if voltage is given by 160 sine omega t plus 30, current is given by 5 sine omega t minus 200. What am I saying? Look at here. Frequencies are same, therefore, and sine is also same. You can take only phase angle. Look at the phase angle and multiply. And moreover, he is not asking the power or real power. He is asking reactive power. Reactive power means what? VI sine. So we need to take sine. So come with me to the solution. Please follow me. 160 by root 2. Because I am calculating RMS power. Please understand. By default, AC means RMS powers we take. AC means RMS powers. So 160 by root 2, 5 by root 2, sine 210. Why 210 is given? Observe that. What's the meaning in that 210? And if you give 210, come with me here. I'll show you back. This is 10. This is minus 200. That means suppose you take 0 here, 10 this side, minus 200 this side. What is the total effective angle? 10 plus 200. That's why it is 210. It is not 190. So don't put 190. And the answer will come as 200 volt ampere reactive. The unit is, because this is a reactive power, volt ampere reactive power. This is the meaning of how to calculate the powers. Problem 12. Current through a 10 ohm resistor in series with an inductance is given by I of t 3 plus 4 sine 100t plus 45 plus 4 sine 300t plus 60 amperes. Find the RMS value of the current and the power dissipated in the circuit. We have to calculate RMS value of the current and the power dissipated in the circuit, right? This is given in gate 95. And this is only given for 1 mark. You must understand how small it is. Problem is very big, but the solution is very small. Now look at this. RMS value 3 square plus 4 by root square, 4 by root 2 square, everything under root. 3 square is a DC value, 4 by root 2 is a AC value, 4 by root 2 is a AC value. So total is 5 amperes. What's the power? IRMS square into R. So IRMS square means 5 square. 5 square is 25 multiplied with 10. So 250 watts. Now if you observe your ABCD, you can say answer is C. So this is the meaning of how you have to calculate. So once again I am telling you, this is a DC term, directly 3 square, 4 by root 2 square, 4 by root 2 square under root. So that is the value of how to calculate effective RMS value. Next problem. This is something with diodes. So don't be panicked when you go to active devices. See, in the circuit shown in figure, diodes are ideal and meters indicate average value. Then the meter will read what's the value. The first thing, whenever you see any active circuits, I'll give a small hint or a general idea. Draw the equivalent circuit by saying whether it is on or off, and then analyze. What I'm going to do now, take this circuit, you are giving a sine value. For positive angle, what is happening to diode? For negative value of this negative cycle, what happens to diodes? The first thing you need to decide, is it passing half wave or full wave? Ready? Let's enjoy this. Let's go to the solution there. Look at this. When you give positive, this diode is off. This diode is on. So one diode is off, other diode is on. By that, understand. So diode 1 will conduct for positive and the diode 2 will not conduct. That means this circuit is acting as what? Half wave. So the first decision you have to make is it is acting as half wave. When it is acting as half wave, again the next question comes, is the ammeter. Ammeter will read what he said. He said the ammeter will read average value. So average voltage by R, Vm by pi by R. So 4 by pi, 1 by 10 kilo. Kilo becomes milli. So 1 by 10 will become 0.4. 4 is the peak value here. 4 by pi is the DC value. DC voltage by resistance will give DC current. So please observe these two. Draw the equivalent circuit. Decide whether it is full wave or half wave. Then also decide whether you want RMS value, or suppose if this meter is AC meter, it will read RMS value. But he said it is going to read average value. In another exam, he said moving coil ammeter. So moving coil ammeter reads what you should decide and according to calculate. Definitely he will give the hint whether the reading going to be DC value or average value. So the option is D, 0.4 by pi. 14. An input voltage V of t, 10 root 2 cos t plus 10, 10 root 2 root 5 cos, 10 root 5 cos 2t plus 10 volts is applied to a series combination of resistance 1 ohm and inductance of 1 Henry. The resultant steady state current how much? Please understand, this is also multi-tone signal. How many tones are there? One is omega is equal to 1, other is omega is equal to 2. This is given for a series RLC circuit. So impedance is nothing but R plus j omega L. If you say omega is equal to 1, that becomes the first tone. If you say omega is equal to 2, it becomes the second. So you have to calculate, and effective values you have to substitute here. And please observe in the options given, he is not asking you to calculate tan inverse. He himself giving tan inverse of 2 directly. So tan inverse of 2 is directly given. That's the meaning. Good idea? So tan inverse of 2 also you don't need to calculate. That's what it means. It is given in GATE 2003. Shall we go to the solution, please? Look at the solution. I is V by Z. Z is R plus j omega L. What is first one? 10 root 2 cos t plus 10 by 1 plus j, because omega is 1, L also 1, R is 1. So R means 1, j is here, 1 is omega, L is omega. Therefore, Z becomes 1 plus j. Similarly, 10 root 5 cos 2t plus 10 degrees by 1 plus 2j. So 10 root 2 cos t 1030, angle of what? You look at the angle of the first one. What is the magnitude of this? Root 2 angle 45. What is the angle of the second term? root of 1 square plus 2 square is 5. Root 5 angle tan inverse of 2 by 1. So this effectively what happens here, 45 and 10. So 10 minus 45 is how much? Why should I say minus? When the lower one, when the denominator goes up, it is 10 minus 45. So it is minus 35. And when the angle here is 10, that will be there as it is. Tan inverse of minus 2 will go here. So therefore, effectively 10 cos t minus 35, 10 cos 2t plus 10 minus tan inverse of 2. So this is the angle created by this circuit. So when you are calculating impedance also, you should take tone by tone. So how to handle the impedances for multi-tone signals? The word multi-tone signal is a very popular signal. In fact, if it is not a multi-tone, it's not a signal. For any signal to contain information, it should have more than one frequency. So I want you to learn multi-tone signals here, then take into signals and system, then apply in communication system. So multi-tone signal will always contain information. That's why right from the electrical circuits I am introducing this. Not only me, you can see how examiner is interested in multi-tone signals. Next one, 15. An AC source of RMS voltage 20 with an internal impedance of ZS1 plus J2 feeds a load impedance of ZL7 plus J4 in the figure. Calculate the reactive power consumed. This is GATE 2009. Because as you see, reactive power, the unit will be volt ampere reactance. So volt ampere reactance is the power. So 20 angle 0 given, ZS is here, ZL is here. Once you have ZS and ZL, you need to calculate the total current is first, and after that you need to multiply with the reactive term. So these are the two steps involved in this problem. First calculate I, then calculate reactance. Substitute there. So remember 1 plus J2, 7 plus. If you calculate the total, 1 plus 1 is 8, 2 plus 4 is 6. Come with me to the solution. Current is always voltage by total impedance. 20 angle 0 is the voltage. Total impedance is 8 plus J6. If you calculate these values and multiply them, you will have 2 angle minus 36 by this. Okay, 2 angle minus, angle becomes minus because you have to calculate the root of 8 square plus 36 square, or 8 square plus 6 square. 64 plus 36 how much? 100. 100, 20 by 100, and under root means what? Root of 100 is 10. So 20 by 10 is nothing but 2. What is the angle? Tan inverse of 6 by 8. If you say tan inverse of 6 by 8, it is 3 by 4, that is 36.86. And then angle comes up, it becomes negative. Therefore, this angle is, the value is I square is 4, XL is 4. Because XL here, this is 7 plus J4 that I am substituting. That's why it is called I square into XL becomes 16 watts. So the option is B. The option we have. Among the given options, it is B. Let's go to next problem. The voltage phasor of a circuit is given 10 angle 55 and the current phasor is 2 angle minus 45. Then calculate active and reactive powers in the circuit. Very simple. He is simply asking you one word. He is checking you whether you know active power means what and reactive power means what. For us, active power means VI cos phi. Reactive power means VI sin phi. For active power we say watts. For reactive power we say VAR. So you look at that units. Look at the options given also. Active power he has given in watts. Reactive power he has given in volt amperes. Right? So let's go to the solution. Active, as I told you, VI cos. So 10 root 10 to cos. So this is 20 into 1. What is cos 60? 10 into 2 is 20. Cos 60 is half, 10 watts. Then reactive power. VI sin 60. 20 root 3 by. So 17.32. So what is option here? Option is A. So this is how you can calculate the active powers and reactive powers. So this is all about AC circuits. AC circuits are almost over. We are left with only one topic called filters. That we will be seeing, and that will complete AC analysis. That's the fourth important part of the circuits will be over. In fact, we can also see filters as a separate chapter because it's not there for ECE, but for EEE it is there. This is what it means by AC circuits. Under that, we have seen about different AC factors and different AC powers.